you would. You would. Wait for me to push play. Thank you. So our focus today is on graphing, linear equations, and then functions. And of course, from what you've already picked up from before, linear equations, functions, very, very similar. Something to be said about functions that makes them a little extra special. And we'll talk about those as we come to them. Here are the objectives that we're going to hit. In order to be able to do those, is we're going to interpret a line of a graph, plot ordered pairs, find ordered pairs that satisfy a given equation, graph lines, find x and y intercepts, recognize when a line is vertical or horizontal, use the midpoint formula, and if we have time, then we'll try to mess around with the calculator and graphing those. If there's no time, it's not a big deal. We do have them up here, we can mess around with those. It looks like we have a lot of objectives, but they're just going to go by really, really quickly. Okay? Questions on anything? Where's your mind at?
I'm playing every year.
You don't feel good?
I saw him walking to school.
Walking?
Like I pulled over and asked if he wanted to drive. He's like, no, I'll walk. I was like, okay.
He was.
He's not here yet.
I would text you right now.
What happened?
I said I would text him, but I can't.
Would you please, if I ask him? Make sure he's okay. Just want to make sure he makes it okay. That he's not dehydrated, like sitting in the curb somewhere. That can happen. It's hot.
You ever walk up to a random house and ask him?
Thank you, Sincere. Appreciate that.
He was right by the Dollar General.
Okay. Can I change the slide? Thank you, Sincere. All right, so objective one, interpret a line graph. Usually we just get a line that looks like that, and then we get like maybe some X numbers and some Y numbers. That's just practice stuff. That doesn't give me any useful information. Hopefully we get into the habit of adding some context. Kind of like here. I know this is a little bit overboard, but at least there's context there. I know what my X is talking about. I know what my Y is talking about. In this case, we're talking about X being the number of years. And up on top, we're talking about spending in billions of dollars on what?
Medical care.
On medical care. So I can see that the cost of medical care is increasing as the number of years increase. That's simple. Interpreting it, I can see that the cost and spending is increasing every year. And of course, we all know that we can find the line of best fit or do a linear regression to find, the one that we use to guess. But that's a little bit more raw there. Okay, it looks pretty linear. I'm pretty sure we can probably find a line to match that. But right now, what we care about is being able to interpret what it's telling us, and that is that spending is increasing as years increase. Changing Y over changing X. Right? AKA slope. Questions on this? Rara? All right, let's change slides. Let's talk about plotting ordered pairs. I hope by now we can all plot an ordered pair, except for James. James is still working on it. I think he'll get there soon. An ordered pair, usually we get them in the form of X comma Y. What does the first number tell us? How many units to move on our x-axis? So this, someone beat me? So this will tell me how many units to move in this direction. The y value will tell me how many units to move in the up-down direction. Okay? So here's an example. We have -3, 1, -5, 6, and 4, 1. The 3, 1, I'm going to move 1, 2, 3 units on x, and I'm going to go up 1 unit because that's a positive 1. So there's the graph. There's the graph, Versa Ramos, of 3, 1. Any questions on how I graph that? Too easy, it's beneath me. Just some things to remember. This is called the origin when you're at 0, 0. That is the y-axis, and that is the x-axis. Let's move on. Ah, yes. And this thing, and I think I mentioned that before, this is not the graph. This is not the graph. This is the Cartesian coordinate system, the coordinate system the rectangular coordinate system, whatever you want to call it, but it's one of those. The graph is like that red point that we put on here. That is the graph. Okay? Moving on. What else we got? Good stuff here with the quadrants. Sometimes we do forget. We start with quadrant 1 and we move counterclockwise. This would be quadrant 2, quadrant 3, and then quadrant 4. There are some rules about these quadrants. If you're in quadrant 1, both of your coordinates on your ordered pair should be, they should both be positive. So notice these are both positive values. Over on the quadrant 2, you should always get negative first, and then a positive. Quadrant 3, they should both be negatives. And finally, a positive with a negative. If they do not follow that order, you are in the wrong quadrant. You have graphed it incorrectly. So be careful there, please. Okay? Questions? Boom shakalaka. Finding the ordered pairs that satisfy a given equation. So, here's an equation. We've got 3x minus 4y is equal to 12. And they want us to find, the corresponding piece to what they've given us. So, the way this works, in this case we have 0 for x. If we plug that in to the x position, we should be able to find the other variable. 3 times 0 is gone. That's going to give me negative 4 is equal to 12. And of course, once I use my division property of equality, I find that y is a negative 3. And that's why I've written a negative 3 in my y part. So yes, if you do have a 2-column table, all they are is an ordered pairs in 2 different columns. So you put all the x's together, all the y's together. Okay? Should be nothing new, right? And if we want to find the other corresponding part, then I should just use this. Then we'll do the same thing by plugging in for the y value. So I've got 3x minus 4 times 0. That's equal to 12. I know this is going to drop out of the picture, which is going to give me this bit. And I find that the corresponding x is going to be a 4. So there's my 4. Go ahead and find me the negative 2, the x that corresponds to negative 2 on the y, and the y that corresponds to negative 6, please. Give you guys a few minutes. I'll give you a minute, actually. Interrupt me, Moosh. remind you that we're recording this live. And the microphone picks up everything in the classroom. Max, what'd you get for the corresponding x on the negative 2y?
403.
You got 4/3? Can I get a second on that? And a third? Got a second and a third. All right, what about the negative 6? Lexa, what'd you get? What's the corresponding y? Negative 30 over 4. Okay, that becomes negative 15 over 2. Good job. All righty. What's up? 15 over 2. Yeah, we just simplified it. The negative can be on the bottom, on the top. Here, you can write it this. Let me show you all the different ways. You can do negative 30. Actually, I should say 15 because we simplified it. So you can do negative 15 over 2, 15 over negative 2, or you can do negative 15 over 2. Any one of those is the same thing. Okay? Thank you. Jeremiah, do you have water?
Yeah.
Okay.
Nah, I overslept, that's why.
All right. We're going to move on. Questions on this problem from anybody? Okay, graphing lines. Here we go. Thank you. Graphing lines. Linear equations, two variables. Here is the standard form of a line. Should be in the form of ax plus by is equal to c. Copy my notes. That's funny. That was good.
Can you like edit some stuff?
I always leave it. It's just funny to go back and hear sometimes. Stop copying my notes.
Okay.
One thing I do want to point out, ax. When you put these in standard form, a should never be negative. It should always be positive. The b can change to be negative or to be positive, however you want. But you make sure that that a is always going to be a positive number. Okay? Questions on standard form? I think you guys have seen that a billion times, right? Can I change the slide? Yeah? All right, moving on. Cool. Finding x and y intercepts. X and y intercepts are actually a pretty simple thing. If you go back and you think about, here's a little graph here. Oh, is that not that little? Never mind. If you think about this point here, can someone give me a reasonable coordinate here? 0, 3 sounds good. Okay, but that will always happen. You will always get a 0 for the x position because you don't move left to right. Okay, so whenever you see a 0 on the x position of a coordinate or even on a table, you should be able to identify that as the y-intercept. Okay, same goes for an x-intercept. These should always be in the form of some number, comma 0. Okay, so if you notice that there's a 0 in the y position, then guess what? You have something called the x-intercept. And I think they'll call this 0, comma b. Right? Little b. That's usually what they'll call it, but
That was H. Oh, wait, that was something else.
that's the shifts. Those are the shifts. It doesn't have to be b. Remember, b is just a variable. If you see a 0 at the beginning, you're looking at a y-intercept. You see it at the end, then you're looking at an x-intercept. And that's exactly what we just said. Is that our graph? Yep, there's a graph of this. All right, so pretty simple to see. I can see right here I'm crossing the x-axis. That is 2, comma 0. I just found the x-intercept. Right over here I can see I'm crossing the y-axis. That's going to be -4. Well, which one's wrong? The first one's wrong. This one's 0, comma -4. And there you got your y-intercept. No big deal. Things we've been doing already since. What's up?
How did they get the y-intercept from the equation?
How did they get the y-intercept? So, if you're trying to figure out from the equation, let's say this wasn't here. That's a good question. Go away. I've got this equation, 2x minus y is equal to 4, right? And you want to find the y-intercept? If I want the y-intercept, what do I know about the x? It has to be 0. Right here, sorry. That means that when I plug a 0 in here, guess what happens? All that's gone. So now all I have to do is divide by a -1, and y is equal to a -4. And the same is true about the x-intercept. If I want to find an x-intercept, I'm going to make the y 0. Okay? Questions, anybody? You got it. Oh, you stay. You go. Oh, I'm not going to be able to get all this back. Will they grab it? Yay, it did. Not too bad. I don't want to push back that many times. I didn't want to hit back like 20 times. It would have probably grabbed it. Did I forget the dot? Is that what you're saying? Can't have a graph without a graph, right? You're cold? I thought you'd be like, yeah, I thought you'd be pretty. No. Alright, my bad. Just trying to help you out. Alright. Can we change the slide? Recognizing equations are going to be vertical or horizontal. I have the equation y equals 3. What does y equal?
3.
When? Always. Y will equal 3 always. It doesn't matter what you pick for x. Guess what y is going to be? 3, because it said it. So that means that when I go 1, 2, 3, everything that I pick, whether it's here, it's going to be y equals 3. If I pick 2, y is going to be 3. If I pick 3, y is going to be 3. 4, 3, 4, blah, 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 blah. Y will always be 3. So when you see a y equals, think about that.
All you gotta do is put one line on the number.
Right across every single 3, because y will always be 3. Not sometimes, all the time. What if x is infinity? Y is going to be 3. Okay? So the way I remember it is which line I'm going to cross and where. And if this is the y, I got to cross the y, and I'm going to do it at 3. Okay? You got something else that helps you? Do that. But that's just the fact of the matter there, okay? Y will always be 3. Same thing can be said for these guys. In this case, I only have an x, right? And you guys can see that's going to be x is -2. What will what's x equal to? When? Always. So I go over to x at -2, and I'm always going to be here. So there it is. X equals -2. Will always be that. Okay? Questions?
Is it just different when they throw an x and y into the thing?
Well, if you have an x and a y, now it's going to have some slope to it. So it'll behave like this. Oh, bro, do me a favor. Yeah, well, these just go back to the office. First hour, just like she didn't want to pass them out, she just dumped them on my desk. It wasn't even the right room. All those, and then she missed this person, and I didn't have anybody second. So, thank you. Are you the key master? Jessica Mercado? Jessica? Do we have a
Who? Jessica Mercado.
not in here. graph this. Go. You graph this, please. I'll just send it back. When do you see your next hour? At lunch? Yeah, I'll probably get to her sooner than. What do you eat since here?
No, I was talking to that.
Oh, yeah.
So is that your microphone windows?
No. It's this one over here that's got all this electrical tape on it. I had to piece it together.
What is that? Camera?
That's the camera, but because I used to have a little picture of me up there, but like after a day, it stops and it doesn't talk anymore, and I'm too short to go up there and reset it.
You want me to reset
Wait,
it
so
for
it's
you?
like recording the screen?
You can't even know.
Get JT to reset it.
He does, but I don't see him till the end of the day.
I thought you just screen this one with that.
Yeah,
We got you.
but I used to have a picture in there too. Not no more. What's up?
So it don't work.
It works. It just like after a while, it just like doesn't talk to it anymore because it's wireless. I've got a little USB thing over here. I kind of like it, but I don't like it because you know how they say the camera adds a couple pounds. I'm already a little heavy. I look like the Stay Puft Marshmallow Man. All right, let's call somebody.
Oh my god.
Marissa Ramos.
We literally just watched your call.
Come sketch it. You haven't done it? I said participate. I didn't give you the extra one. Okay. Let's just do these really quickly because it shouldn't take a long time. I'm not even sure why we spent a whole year, freshman year, doing these for like 4 months. But we did. It happened. What do we always want an equation to equal? We want it to be y equals everything else, correct? So I'm going to move this y from here to here. That's going to make this 3x is equal to y, or in other words, y is equal to 3x. No, that's the equation I want to graph. Questions on how I got to the equation?
Yeah. How did you get there?
So I started by swapping that y from here, bringing it to the other side, which made it a positive y, right? And then I just flipped it. I wrote it backwards, see? This is Sparta! There are... Thank you. Thank you. Thank you. Thank you. I need another one so I could make it an arrow. But here's what we did freshman year. And a lot of your junior year too and algebra 2. With lines, they can only do 2 things. You guys know what those 2 things are?
Yeah.
They can move up or down. No. They can't move side to side. Lines only move up and down. And you can change how slopey they are. So you spend the whole year learning that lines only do this. That's all they do. Up and down, change your slope. So in here, I need those 2 things. Where is my y-intercept? Well, there isn't anything there, which means it's 0. And then from there, I do rise over run, right? That means up 3 and to the right, 1. 1, 2, 3, 1. There's my next point. You only need 2 of them.
Wait, where'd you get the one?
Yeah, wait, do it again.
I made this a fraction. Because I want to have a rise and a run, always. So in order to make a whole number a fraction, I just put a 1 under it. I think the ones with fractions are much easier than the whole number ones. That's it. And you could do it again and again. 1, 2, 3, another 1. You should be back. Whoop, you should be back on the line somewhere. And if you want to do it in reverse, you can too. Okay, you would go back 3. Do the opposite of those. Questions on graphing lines? All right, midpoint formula. You guys ready for midpoint formula? I think the second to last thing we got to do. Sincere, help me out. Help me out. What is the average of 2 and 4? 3. How'd you do that? You found out the number that was in between. What's the easier way to do it? Add the 2 and divide by 2. They gave me the middle, right? Remember that?
Yeah.
So 2 plus 4 gives me 6. 6 divided by 2 gives me 3. Well, guess what the midpoint formula is? It's exactly that. If you're trying to find the middle of 2 points, add the x's, divide by 2. That'll give you the x coordinate. Take the y's, add them up, divide by 2. That'll give you the y coordinate for the midpoint. That's all you got to do. Do not make it any tougher than that. Well, they'll give you the coordinates. They'll say, hey, what are the midpoints of these coordinates? Or what's the midpoint of these coordinates? Can I change the slide?
Yeah.
So here's an example.
Wait, go back.
Okay. No running. Huh?
Never mind. She's done.
Can I change the slide now? All right. So here's my 2 examples, Mason. I've got -5, 8, and I've got 2, 4. And they want me to find the midpoint of this. What is -5 plus 2 divided by 2? Well, that's going to give me -3 over 2. So that means that the x part is going to be -3/2. Looking at the y, I've got 8 and 4. Would give me 12 divided by 2, which is 6. So the y value is 6. And there's your midpoint. There's your midpoint. This is so difficult.
And it's just x1 minus y1, or no, it's x1, x2, right?
It's just add the x's. Just add the x's and divide by 2. Add the y's and divide by 2.
Wait. Oh,
What's up?
never mind.
Remember, addition's commutative, right? So it doesn't matter how you add them, as long as you do it. Guys, thank you for your patience. We're almost there. Yes, we are. We can skip the last part if you want. Do you guys want to skip the calculator one?
Yeah.
Everyone know how to plug equations into the calculator? Someone not know how to do that? When I'm walking around, you can ask me then. All right, then I'm going to stop this here, and we are